Hi everyone, today we're going to take a look at moving around the sine graph one more time. Just want to do a quick review with you on a sinusoid. Okay, the formula, in case we haven't run over it in class, would be A sine bx plus c plus d. Okay, we know that the amplitude is the absolute value of A. We know that the period is going to be 2 pi over the absolute value of B. And then, as we've talked about in the past, okay, the D on the end is going to control whether we're moving or shifting up and down, and the C inside is going to talk to you about whether we're going to shift to the left or to the right. I guess it really doesn't talk to you, but you know what I mean. All right, so up here at the top, all right, we have y equals sine of 2x. Okay, so this one's new because I have a value other than 1 as the coefficient of your x term. That happens to be b. Okay, so we'll drop this in here. So in this equation, our b is 2. So b is going to affect the period, okay, which I put up here in red. So the period for this sine of 2x is going to be 2 pi divided by the absolute value of 2. Okay, so that's just 2. So that comes out to be pi. Okay, so what does that mean for us? Well, that means that from 0, switching colors on you, from 0 to pi, okay, or say 3.14 because we're doing things in decimal, from 0 to pi, so here's 0, pi is about 3.14. Okay, so between those orange lines, we will have one cycle of your sine graph. Okay, so if we take a look here, if we think about that, oh, I should ask you too, do we have any change in amplitude? Okay, or what is the amplitude? Amplitude is just going to be 1 because you have a 1 for a coefficient first in front of the sign, and we don't see anything moving up and down, okay? So, or left or right. So that means to start out, we know that at 0 and at 3.14, we're going to be at 0, okay? Halfway in between there, there's also a 0, which by now we should recognize as 1.57. Okay, then halfway in between each of those zeros, we know we have to do an up and a down, and no reflection, so it's going to be straight away. So halfway between 0 and 1, okay, or sorry, 0 and 1.57, we're going to be up here at 1. Halfway between 1.57 and 3.14, which is going to be a little bit past 2, maybe in there, whoopsie, my bad, went too far. My other grids, I had those at 0, didn't I? Whoa. We got a little crazy going on here. All right, well, how about we just do this? Don't look at this one. Color him in. All right, so up here, a little closer. All right, then you can draw your beautiful sine graph. Okay, amplitude still 1. However, we just have that smashed in there. In fact, if we wanted to do a second period, we could drop this another one out here to 6.28, and we could do the exact same thing again. We could go through and mark our spots here, about halfway between 3.14, I would say it's not quite 5, okay? And then we can drop a point above, one below here at 1, and you could do a second period of the sine graph. Okay, so again, that one we have a period of pi, and it just causes that graph to shrink up a little bit. All right, second one for you. Y equals sine pi over 3x plus 1. Okay, so a couple things happening here. First of all, I see a plus 1. So that's going to tell us that our graph is going to go up 1, okay? We also know that we have a value in here for b, so that's going to affect the period. So we're going to have 2 pi over the absolute value of pi over 3. All right, so now what in the world is that? Well, we could say that's 2 pi times the reciprocal, 3 over pi. Okay, so the pi's cancel, and our period comes out to be 6. So from 0 to 6, we will have 1 cycle of our sine graph. Okay, now before I start that, I'm going to put in my new midline. Okay, midline here is up 1, so I'm going to start with that. Okay, so we've got to shift everybody up 1. And then the period change is going to be from 0 to 6, like so. Okay, and then we can go through and put our graph on here. Okay, so we'll start at 0. And then down here at 6, we have our zeros. Halfway in between at 3. Okay, and then halfway between, so 1.5, we're going to go up 1. At halfway in between here, what about 4.5? We'll go down 1. And again, from the midline. Okay, then we should be able to sketch our graph. Okay. And I do a second period. However, I'd fall off of the grid, so we don't want to do that. All right, so that one you'll see stretches our graph out. Okay, and then I have a space, I guess, for one more. Well, let's see here. Change that up into black. So let's say, I don't know, how about y equals the sine of... Let's find another one that looks like fun. How about this one? Let's do, in fact, let's back this up one. Okay. Yeah, so let's try y equals 3 sine x over 2. Okay, 3 sine x over 2. Okay, so the number in the front, okay, we scroll back up here, number in the front is going to affect the amplitude, okay? So amplitude on this one is going to be 3, okay? Period is going to be 2 pi over, treat that like 1/2 sitting there, 1/2. So 2 pi times reciprocal, 2 over 1, would be 4 pi. Gosh, I didn't pick a very good problem. We're going to fall right off our graph. You know what? We can do this. Let's just make this idea. Let's get rid of this part. Delete. And I'm going to delete here. Just like on the board, we can erase that. All right, so let's make this 3 sine of 2 pi x. Yeah, that's even crazier. I shouldn't have changed my original. Let's make this one be, excuse me, get that 2 out of there. All right, how about just pi x? So it keeps our amplitude at 3. Yeah, sorry for the delay, folks. 2 pi over pi. So we have a period of just plain old 2. What I have up here? We had pi. Okay, that'll be good. All right, so we've got pi x. So I take 2 pi divided by the absolute value of pi. That just drops us in at 2. Okay, with an amplitude of 3. So we're going to go up and down 3. Okay, so let's start things off here. So the midline is what it is, but we've got to deal with that amplitude. So we're going to go up 3 and down 3. Okay, so that should create us a stretch. And then our period is just from 0 to 2. And I've been doing that in orange, so I'll keep that here. So from 0 to 2, we're going to have one period of the sine graph. It's just going to be stretched up and down 3. All right, well, let's see what this is going to do. Okay, so like before, we know that we have zeros on the end, and then halfway in between, we have another 0. Okay, up and down 3. So halfway between, we're going to go up to 3. Halfway between on the end, we're going to go down to 3. And then we can sketch our graph. Okay, if we wanted to, we could do that again. That was so much fun. So let's go out another period. So we can drop that out at 4. Okay, and then we can do the same routine. We have a 0 to start at 2, a 0 to end at 4. Okay, 0 in the middle. Okay, then we're going to go up and then down the halfway, and then we've got a second period. Okay, and you know what? That was so much fun. Let's do it again. So now we can go out here to 6. Okay, and we can change our pen color. We've got 0 at the end, 0 in the middle, up 3, down 3, and whee! We've got another period of the sine curve. Okay, so we are vertically stretching, and we are making that one more frequent, because in our normal 0 to pi, we have 3 cycles going on there. Isn't that lovely? All right, everybody, hope you have a great time when you stretch and shrink your graphs horizontally. Later.